Hello everyone. In this video, I want to have an introduction to SolidWorks CAM. So the goal is not really to go over every detail of that, but I just want to introduce it to you to this amazing, powerful adds-in that SolidWorks has. So as I said, it is an adds-in. So the first thing is you need to make sure that it is already checked. So you go to Tools and you go down to SolidWorks add-ins and make sure that SolidWorks CAM here is what added. Okay, so this should be checked. Then you also need to what? You also need to bring the tab here. The tab is typically not activated, so you right click, go to tabs, then go down here and you should be able to find SolidWorks CAM. Then you get your what? You get your CAM or computer aided manufacturing tab, and now you can start creating the machining program, the code, CNC code or G code, and so on and so forth. So the first thing you need to do, if you have your model, you need to go ahead and create the machine, define the machine, and there are different machines here. There is the mill, 4 and 5 axis, right? And you can choose it to be light duty, medium duty, heavy duty, and so on. So let's just keep it at medium duty, and let's just go with a regular mill. You also have a turning machine, okay, a lathe machine here. So if I select that, and then the other thing you have is the tool crib. So here is basically the set of all tools that are available to this milling machine, and you see there are flat ends, there are ball nose, there are a center drill, countersink, face mill, and so on and so forth, right? And these are different dimensions for them. And if you want, you can remove the tools, you can update them, you can edit them, you can add them, and so on, right? So if you click on add tool, then you can say what kind of tool you need, what is it, the job that it is doing, is it rimming a hole, is it a ball nose, a new ball nose, is it drill, right, is it countersink, or what is it that, are you making a keyway for a gear or something, right? And then filter it based on the material, based on the diameter, protrusion length, and so on. And you can add tools, as I said, or remove tools, and so on. So this is what you have at your disposal with this machine. And as I said, you can add or remove or update. Then this is the post processor for converting your tool path into a code that the CNC machine will read. And I will leave it as this M3 axis tutorial. If you want for 4 or 5 axis, you can change those, right? These are typically updated based on the machine that you select, right? And then there is setup here, which we'll get to it later a little bit. And if you have a rotary axis, like it's a 4 or 5 axis mill, then you can come and select that. So when I show you an example of a 4-axis mill, I'm gonna come back to this, okay? So this is your machine. The machine is selected. You can see that here, and you can always right-click on that machine, right? You can always right-click and go and edit anything that you want. The next thing is the coordinate system on the machine. So you click here, and this is where that coordinate system is. You typically, in a milling, you use one of the corners of the part, right? Typically it's like this bottom left or the top left. So if you see that this is not really exactly what you do in real world, so you can click here, and then what, you can change it. And if the axes are not exactly the way they should be, then you can change that. For example, if x-axis is along the length, y-axis is along the depth, and z-axis is upward, feel free to what? Feel free to change these. So you say, no, y-axis, I want this line to be my y-axis, right? And z-axis, I wanted it to be upward, not like that. So y-axis, reverse it for me, you see? And then z-axis is automatically selected. So feel free to change your coordinate system to match it exactly with the machine. And you should do that if you want your G code to work properly with the real machine. So this is just simulation, but if you want to use the G code with the physical machine, you need to make sure these exactly match the one on the machine. So here the coordinate system is chosen. The next thing is the stock or the raw material that you choose from your inventory, and then bring it and machine it here. So you go and select your stock. Typically it is the envelope of the part, right? And then this is what is called the bounding box, right? Or here we have this basically what we call predefined bounding box, or other methods like extruded sketch or something. And the other thing you can do here is to add to the thickness of the stock part in different directions, right? For example, if your stock on the top surface is not really properly finished and it's a rough top surface, then you want to add here something to the Y thickness, and then let this top face of it be face machined, right? Face milled. So basically you get a nice surface finish on the top, and then you do the rest of the milling. So here, just for simplicity, let's assume that the stock material is with a good surface quality on the top, so we don't need to machine the top part of it, although typically that's not the case in real world. So here just we want to simplify it and go basic. So we choose the stock part, and then once the stock part is there, one of the things you typically need to do is the setup here. And as you can see here, the front plane and the direction of approach of the tool with respect to the part is not right. You see here this arrow and that surface. This is the first surface that is going to be touched, and the tool is approaching like this. So basically it's like you're putting this part vertically like that in the machine, something like this, which is not the way we designed it and not efficient, right? And of course you cannot make any of these. So here you go ahead and change your top face to that, and now you see the first face to be approached is here, and the direction is downward, which is exactly what the machine should do. Now we extract the machining features, the machinable features, right? So as you can see here, it detected for me that pocket, it detected that irregular slot here, and then the whole group, right? Now that they are extracted, I go ahead and generate an operation plan. So right now, if you look under the tree, I have 3 new tabs added. One is this called CAM feature tree, which is exactly where I defined everything so far, right? All the way from the machine, all the way to machinable features, stock and everything. And now the next tab is called the operation tree, and this is how the milling operation is going to be done. So in order to generate the operation plan, you create it here, and it tells you exactly with what tools and using which operation it is going to create this part for me. So you see here, it is going to rough that part with a T04 tool, which has flat end and 0.75 in diameter. Then it's going to contour it. And roughing means removing the material, not to the exact dimension, and contouring or finishing is basically going to the exact dimension and typically removing smaller amount of material. So it's going to do rough and contour that, then rough and contour this guy, right? Then do a center drilling for the holes, and then what? Drill the holes. And the dimension of the holes are exactly 0.5, and see it's using a standard 0.5 by 135 degree drill. And that's one of the things I recommend. If you create holes, make sure they are standard size dimensions, so you can use standard drills. Okay, don't go with just random dimensions unless you really have to. So this is the operation, and now the next thing is to generate toolpath for it. So say, hey, generate toolpath for me. Now each one of those operations, as you can see, if you expand them, they have their own toolpath that you can see, right? And you can visualize each one or simulate it, you can edit it, you can modify it, and so on. Just right click on it and you can see everything about it. Or if you want, you can select this whole group and go ahead and simulate the entire toolpath of the whole operation here. So let's go ahead and simulate that here. So you see this is the stock in orange transparent. The part is in kind of gray or dark gray. And here you can also choose what to be shown and what not to be shown. So if you want to see, for example, the tool shaded, then you choose that. Otherwise, you can say show me wireframe or translucent or no display. If you want the tool holder, similarly, and so on. So you can choose what to be shown and not. Here you can choose the speed of the simulation. Then you can say how far it goes. Does it go from beginning to the end? Does it go to the next tool or next Z level or anything, right? And here, of course, you can go ahead and save it, right? You can also look at the tool cut collisions and so on. So let's say we play this here. And the part that is green is the stock that is being cut, but not to the exact dimension. Then you see here is the finishing or the profile that is going to give you exact dimension. You see now the green is removed and it's all back to the gray. So now it's perfect dimension. It's the final finish. Now it goes over what? It goes over that irregular boundary here. And as you can see, it's not going to cut all of it from top to bottom, because this portion of it here is just going to be what? It's just going to be separated from the rest of the stock, and they can just throw it away. So they are being smart and not wasting the time. You see here, this is completely taken off from the part, so we can just throw it away and not waste the machining time to cut something that is going to be thrown away anyways. So you see now the green material is being removed. It is doing the roughing, and next it is going to do the final finish here, right? So the material is removed, and now it is gonna go ahead and try to do the finish. So now you see the gray parts are appearing, and it is gonna do the final finish for you. Here you can see this is the final round, the final pass, and you see the gray material is being generated, and it's doing actually a very beautiful job. And then it is going to go fast over the holes. You see here, it is doing the centering, and then it is going to do the drilling. Look, center, 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 then drill, 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 and drill, done. And you okay that, right? And the next thing is, if you want, you can step through toolpath. You can modify the toolpath if you want. So you see here, the toolpath of this guy is going like these concentrated slotted holes or something. But if you want, you can go to edit definition, and you can modify the toolpath if you want to or anything. But or you can modify the tool here, right? So this is the tool, right? This is the cutting part, 1.5, which you can see called the flute length. You can change the diameter, you can change the type of it or anything. And the non-cutting portion, so you can change anything you want here. There are so many options here. For example, if you go to the roughing, right, you see the pattern is pocket out, but if you want, you can make it zigzag. So it can go like this. And so it is going to change the way that it is going to do the roughing. So you can okay that, and now if you regenerate your data, now it is not gonna go the same way that it did like this concentric. It is gonna go and do the zigzag here. So you can modify it, right? So let me show you here. You see, look, it's doing a different job here. And clearly this is not really efficient. Okay, it is wasting a little bit time. So typically what SolidWorks is offering you is the best way and the fastest way for continuous operation, instead of jumping from place to place, which is gonna waste a lot of time here. And so my recommendation is really to not change some of the basic operations and the toolpath unless you really know what you're doing. So here I put it back, and then you can go ahead and save your file in what we call a neutral toolpath format .cl, which you can save it, and then you can also generate G-code here. So I say generate it for me as a G-code, and then there are all sorts of different G-codes. So here, let's say .tape file, right? .tap, sorry, or .txt or .cnc. So we can save it like that, and then it is needing to post-process your .cl file to make it your G code or NC code. So you have to run this. So it generates the G code, and then you OK that. And now if I go to my desktop and if I open one of these, either this one or that one, you clearly can see what? You clearly can see your G code here, right? Which you can use in the physical machine. So this is a simple milling operation. For the next example, I want to show you a simple lathe operation here, or spinning axis only. So let's say, for example, this is a rough pawn and a chess, right? And one of the things you see is I'm using a fillet here and trying to avoid sharp internal edges, not only for stress concentration, but also for machining. And you'll see it might not even be able to do a perfect simple lathe operation on that, depending on how sharp you are changing the angles. So here again, I go to the CAM and I choose my machine this time, which is going to be my lathe machine, and I select that. And again, it's gonna have its own tools, and a post processor and everything, right? So here I can choose one of these turn axis, right? One of these post processors and select it, and then go to coordinate frame here. Let's choose it here at the center of this top face. That is good. Then we need the stock, again the bounding box, which is good, and then we make sure that the turn setup is right. So it should be this face here, and hopefully now I have selected everything right. I can extract the machinable parts. So you see here it is doing a face roughing here, then it tries to get that profile for me, and then it is going to cut that end of it, which is in the chalk, and get the part to me. So let's go ahead and create the operation path here. You see here there is a roughing, there is a finishing, there is another roughing and finishing. That roughing and finishing was for the face, then it's for the profile, then it's the cut off at the end. So let's generate the toolpath, and then let's simulate the toolpath. Okay, let's see if it does the job for me. Go ahead. So you see, first it is doing removing the stock to the first dimension that it reaches, which is here. So that's the face roughing and face contouring. So when I said face, actually it's this top face here, not this front face. And now it is trying to get the profile, roughing that. You see, now the tool is different, came. And if you look here, that's interesting. Look, this portion that you see is left in green. This is what the machine cannot cut. That is very important. This is a little bit steeper than the machine can really can really cut for you. Okay, so the machine cannot give you the perfect thing here. Okay, it is very close, but it's not perfect. So you need to if you just have a lathe machine, you better change that angle here a little bit, make it smaller, so the machine can create the part for you. Okay, so if I want, I can go back and I go to my part, and I go to the profile of this revolve and try to modify it. It was a little bit too aggressive for the machine, that it could not do it right. So I bring this guy a little bit back, and I bring this guy like this, and then I put my fillet right here. Okay, so hopefully it can do this guy now. And now if I go back to my machine operation and everything, it is asking me, hey, do you want me to regenerate and update everything? And I said yes, go ahead and update everything. okay, and it regenerates everything and update everything. So now hopefully it can get the job done, okay, and this is very important. So not every geometry that you create with especially machines that do not have a ton of axes can be necessarily done. For those, you need to go to higher axis machines. So for a simple lathe, let's see, which is a 2-axis machine, really, look here. Let's see if this time the profile can be done. There we go. Look, perfect, clean, no, nothing green is almost left. Okay, so this is very important for you to reconsider your designs. And the next one, I'm going to show you a 4-axis mill. Okay, so let's say I have something like this, okay? And since I have features and that has to be milled in different directions, like this guy should go top to bottom and this guy should go left to right or front to the back, it's not possible to mill this with a single 3-axis machine unless you do milling of one face and then take it out and then do the other one. So you can do this with the 4-axis, and I made the geometry very simple. You can, with 4-axis, you can do way more complicated shapes, and 5-axis, literally everything. So here I'm just trying to make it very simple. So I go to CAM and select my machine. This time I go to 4-axis mill and select it, right? And here the rotary axis is not selected yet, but once you determine the coordinate frame and the face, you can come back and change it if you want to. So here, let me choose my coordinate frame, and I put it right here. And again, let me change my XYZ axis, put it like that. And this is the stock. That is going to be the bounding box, okay? And then the mill setup, which I'll make this face the front face. So now if I go back to my machine, it should allow me to, you see here, the rotary axis. You see the rotary axis is about this axis. And I guess that's good, because if I go this way, when I rotate it about that, it allows me to put this on the bed. Right, so X is exactly what I need, and you don't want to rotate it about Y because it's not going to bring this face down on the bed, and about Z as well. So you see here it detected the best axis for the rotary axis, and you can say it can rotate in both directions or just clockwise or counterclockwise if it should rotate it or something. Right, so this is good. That's a good axis. Now let's go ahead and extract machinable features, which of course first it's going to cut this to the L shape, then it's going to pocket this, and then it's going to do the whole group, right? And then go ahead and create the operation for me. You see the operations are all made, which is again roughing, right? And then a contour for L, then a roughing and a contour for the slot, and then a center drill and drill for the drilled holes, and then the toolpath is made. Then let's simulate it. So let's go ahead. So here I'm trying to fast forward a little bit so you don't have to wait over there and just watch this going through everything. Okay, the roughing is being done for the L-shaped profile, and now it is gonna try to do the final finish after this. So this is removing all the material. There we go. So now the finish is done with a smaller tool, which has basically better accuracy, of course, right? And it is going to remove all of that green material on the L-shaped face and on here. And then it is going to go for the pocket. Okay, so you see that contour is being done. Now it goes for this. The roughing is done, and then the contour is done, the center of the holes, and then drilling of the holes, and done. Right? And again, you can go ahead and save it with G code or a CL file. but you clearly saw that at the end of it, when it did everything, now so far the tool was going down. Now at the end, the tool was what? The tool was going left to right, and that was only possible because this is done with the 4-axis mill, where the tool can basically go in different directions. Now the correct thing to do really is to rotate this part, and then the tool again goes up and down. So this animation is not really showing what is being done in the machine. It doesn't show that the part is being rotated 90 degrees, right? And it is instead rotating the tools for you, but you can tell that the tool was able to go in 2 different directions, up, down, and left to right. And in a milling machine, that is not what you typically do unless you have a table that is tilting. So this is done with a 4-axis mill, and hopefully this video was useful to you in showing you the very basics of milling. And then you can do probe operation, like for example, if you have a coordinate measuring machine, right, CMM machine, you can do the probe operation and basically check the dimensions, whether it is being done during the simulation as planned or not. But these are more advanced topics, and if I have time in my future videos, I'll go about them. So thank you so much for your attention, and I will see you in the next video. Thank you.